Welcome to our smart contract walkthrough and deployment tutorial for this small proof of concept project using the Dragon Ball universe. So we've created this small project here where we'd use DBS tokens, i.e. Dragon Ball Super tokens, as a digital currency to interact with the world of Dragon Ball. These tokens would then allow you to mint, purchase, and sell unique Dragon Ball NFTs. You could then have a collection for each representing a distinct character from the series, and potentially, for example, having their own particular traits if you were doing some kind of card game, for example. So this is what it will look like, but first I'd like to use this first session to go through the code and have a better understanding of what is going on. We have this getting started README file on the root of the project, which should help set everything up and be able to use this in your local computer. So in this project, we have some reading resources, the ERC20s, documentation from Open Zeppelin and 721s, which is the NFTs. So I would highly recommend you read through those to get a better perception and understanding of how they work before getting started. So before we'll go through the setup smart contracts part, I would like to just go through the actual smart contracts so you understand a bit better how they work and what they're doing. So they'll be under the smart contract folder and contracts. And we have two smart contracts here, the super token and the super ledger. The super token is quite simple. We're just importing the ERC20 from Open Zeppelin and passing in an initial supply. We have a particular name that we're attributing to the ERC20 and also a ticker name here called DBS. And the function that will immediately mint the initial supply straight to the deployer, which is the message sender. Here, the Dragon Ball Super Ledger contract, which extends the ERC21, which is the NFT standard from Open Zeppelin. And a few other things to add some more functionality, such as storage enumerable and ownable. Counter here is quite simple. It's just the only functionality here is to increment the counter whenever there's a new NFT to keep track of their IDs. We have the community token, which is the ERC20 we just discussed on the super token Solidity file. And we have a few structs. So here, well, in case this is just one struct, sorry, which keeps track of the NFTs that are for sale. So this will have the token ID, the seller, the price which it's at sale, and whether it's for sale or not. Then we have a mapping indicating the UIN, so the token ID, to the struct of the NFT itself, which will be called sale items, so the items that are on sale. And then we have a few events that will get triggered when these actions are completed. So when there is a sale, the event for a sale gets triggered, and when there's a purchase, the event for purchase gets triggered. In the constructor, we only have the community token gets passed in and stored within the Dragon Ball Super Ledger contract, along with the name and the ticker of the NFT. Then we have our minting function. In this minting function, we pass in the URI, which will contain the image of our NFT, the price in community tokens, that is in DBS, and whether it's going to be immediately listed for sale or not upon clicking mint. Then we have only owner, so only the owner can actually perform this action. Then we take the current token ID counter, we increment it to create a new NFT. We then mint it, we set the token URI, which will give the image to the actual NFT. And if it has been indicated to put for sale, then it gets added to the sales item data structure with a new incremented token ID. And there we go, we've added a new NFT for sale. And then once that's done, we emit the event to declare that it has been for sale for this particular price. We then have some more utility functions. We have here, for example, the burn function as well, if you do so wish to burn your NFT. Here I skipped, but we have also the before token transfer. So this is mainly just kind of doing a check before transferring a token, making sure that once it's transferred is no longer for sale. which says here in the comments as well. We have some getter functions. So this is to get the token URI, get the current token ID, list the NFT for sale. So here in this case, there's a few checks again. So this function requires that the owner of the NFT is the person triggering the function. Otherwise you get this error message. And also to make sure that the token is not for sale before actually triggering this function. Otherwise it will just say that it's already for sale, so you can't execute this action. And yeah, then it just puts it for sale and emits the event to say it was for sale at the price defined in the current struct. We also have the buy NFT function. So this will pass the token ID of the NFT we want to purchase. It also does the kind of checks again. So it requires that the item is for sale. If it isn't for sale, you can't really buy it. And that the balance of the person that triggers the function, so the MS sender, is higher than the price of the item he's trying to purchase. We also don't want the seller to be the same person as is buying, otherwise you're kind of buying your own NFT, right? Once that's done, we then pass in the seller address to the original seller, and we do the transfer, and then we remove the item from seller, and we reattribute the seller field to the person that it was sold to, or the person that bought the NFT. Once that's done, then we emit the event to really declare that the NFT has been sold, which then gets propagated through the blockchain. Finally, we have get sale and item. This will basically just get the NFT that you pass in. So if you pass in a token ID, we'll get the complete struct of the NFT that is for sale. We also have update sale price. So this will simply, as it says, update the sale price, does a few checks like we've done before. And then once that's done, it updates and also emits an event with the new price that was passed into the function. Then here we have another getting function. This will get all of NFTs for sale. So iterate through the entire count of NFTs and will return a struct with all the items that are currently for sale, which is what this check here does. And finally, the last function is get sale item details. So here does a check just to make sure that the item is currently for sale. And then when that's done, it returns the details of the item for sale. I would like to discuss a little bit more of the framework we're using. So we're using Hardhat as an Ethereum development environment, which helps us to kind of compile, deploy, and do everything with our smart contracts a lot easier. These tools are super important since they're community trusted smart contract libraries, and they simplify the development and ensures that you basically build standard compliant blockchain applications. So here in this case, I'm showing you now the Hardhat config, which is situated at the root of the smart contracts folder in this project, which basically adds the configuration for Hardhat. And in this particular case is quite simple. All this does is to making sure that we are defining the different networks that we may be using. In this case will be the devnet, testnet, and mainnet of Taraxa. So all this does is it defines the chain ID for all these and also extracts the environment variables which are situated in your .m file and extracts the URL and the private key that you'll be using to deploy the smart contract. So if we go here to this .example file, you would have to then create a .env without the .example file and input this in there and just add your private key of the wallet you're going to be using. I highly recommend using a separate wallet from whatever wallet you have for your personal belongings or your personal holdings, as it diminishes the risk of anything bad happening. If you are doing development, please use a dev wallet for that and a fresh one to do that if possible. So once that's done, we should be able to kind of set up the contracts and go ahead and deploy them. Now that we've gone through the contracts and the Hardhat config, We'll go now through the set of smart contract stage. So what we're going to do here when you do yarn install is just going to install all the necessary packages that you need. Because I've done this before, it completed very quickly. This may take a little bit longer for you. And then we're going to actually deploy the contracts using yarn deploy testnet. Just so to clarify why these scripts are called like this, it basically all comes from package.json, where we've predefined these scripts that you can find here. This is just for clarification. If you do want to do any other kind of scripts, you can just add it here as an extra row with the actual command, the bash commands found here in the string. So here what we're going to do is deploy to testnet, sorry. So we'll just fire it off. And now what's going to do is it's going to compile the smart contracts and deploy them to testnet. While this is happening, we're just going to look at the script that it's doing this. So all it does is imports the ethers from Hardhat to be able to interface with the blockchain. We then define our total supply. So this is the total supply of our token. In this case, it's 10,000 because it's multiplied by to the 10 to the 18. Then we get the contract factory from our super token. We deploy it with the total supply value that we define here. Once it's deployed, it will log the address of the deployed contract. And then we can deploy the super ledger itself and pass in the contract address of the DBS token that we just deployed, then deploy that and also log the address of the deployed NFT contract. So here we go. As we're talking about this, it's already deployed here at the bottom. So what you can see here is the contract deployed on Taraxa testnet. So the last thing I wanted to do in this video before we move on to the kind of front-end section of this tutorial is to simply grab this address and actually import it on MetaMask. So we can actually get our tokens. So here, if you go to import tokens, you paste the token contract address that we just created. And as you can see, it automatically detects the token symbol name, which is DBS. And then we import it and boom, we have our 10,000 DBS tokens that we just created, imported to MetaMask, and here they are. Created our DBS tokens and imported them on MetaMask. We've concluded the video here, and the next video will set up the front end with IPFS and showcase the functionality of buying, selling, and minting NFTs. So look forward to seeing you in the next video.